Moving on to steps to design an experiment. This first step is to identify the problem to be solved. The statement of the problem should be as explicit as possible and should provide the experimenter with direction. The statement must also identify the response variable and the population to be studied. Often the statement is referred to as the claim. Step 2 is determine the factors that will affect the response variable. The factors are usually identified by an expert in the field of study. In identifying the factors, ask what things affect the value of the response variable. After the factors are identified, determine which factors to fix at some predetermined level, which to manipulate, and which to leave uncontrolled. Step 3, determine the number of experimental units. As a general rule, choose as many experimental units as time and money allow. Techniques exist for determining sample size, provided certain information is available. Step 4, determine the level of each factor. Factors can be dealt with in two ways, control or randomize. Control means to either set the factor at one value throughout the experiment or set the level of the factor at various levels. Randomize means to randomly assign the experimental units to various treatment groups. Step 5, conduct the experiment. Replication occurs when each treatment is applied to more than one experimental unit. And then step 6, test the claim. Inferential statistics is a process in which generalizations about a population are made on the basis of results obtained from a sample. If you remember about inferential statistics, it contains your percent of confidence and then the range. So, for example, we could say we are 95% confident that the average height of a CVTC student is between 50 inches and 65 inches. So I stated my 95% confidence, and then I stated the range. Sorry, these numbers were made up, but as long as the idea is made clear, that is what is important. Moving on to an example, let's follow these steps. Lipitor is a cholesterol-lowering drug made by Pfizer. In the CARD study, the effect of Lipitor on cardiovascular disease was assessed in 2,838 subjects ages 40 to 75 with type 2 diabetes without prior history of cardiovascular disease. In this placebo-controlled double-blind experiment, subjects were randomly allocated to either Lipitor 10 milligrams daily or placebo, and were followed for 4 years. The response variable was the occurrence of any major cardiovascular event. List the 6 steps for the Lipitor study. The first step is to identify the problem to be solved. So we want to determine whether 10 milligrams of Lipitor daily reduces the likelihood of having a major cardiovascular event in 40 to 75-year-old subjects with type 2 diabetes without prior history of cardiovascular disease. Step 2 Determine the factors that affect the response variable. So what's going to affect the occurrence of a major cardiovascular event? Your diet, exercise, family history, level of cholesterol. That's just a few. The list can go on. Step 3, determine the number of experimental units. They had 2,838 subjects in the study. Step 4, determine the level of each factor. So we had 10 milligrams of the Lipitor or placebo. So although it was not stated, researchers most likely fixed the diet and exercise. Family history. So we just addressed the first two in step 2, diet and exercise. They're being controlled. Family history cannot be controlled. So we're going to randomly assign these to the groups. When you do that, this averages out any family history. So when you do random assignment, it's used for things that cannot be controlled, like your family history. Step 5, conduct the experiment. So subjects were randomly assigned to either the placebo or Lipitor group. There were 2,838 replications of the experiment. Step 6, test the claim. The inferential statistics suggest that Lipitor group had a lower rate of major cardiovascular events. With step 6, like I said up above, we'd usually write our confidence level in a range, and that is always true, but with this case, we weren't given that information, so we're not actually projecting that inferential statistics to the population. All we can say is that by the numbers given here, up above, that Lipitor had slightly better or had some kind of a effect on lowering the rate of the major cardiovascular events. We would actually need the data to be able to say how confident and to what effect.